You just need to figure out that, okay, these are the things that I need to apply and now I'll be able to solve anything. None of these things will ever have a home if everybody just chooses to do that thing that has the immediate demand right now. So you're always skeptical about any information that comes. You go Google something and somebody says something, that is not proof that that is true. So you give them questions that they're supposed to answer, and everybody comes up with their own weird, unique ways of solving. And the question shouldn't be something that you'll be able to go and, nowadays go and ask ChatGPT for an answer. It should be something that you can use ChatGPT for your answer, but it will not give you your entire thing because nobody else has asked this particular kind of a question in this particular way. And that that can, give you this specificity to each student, because each student is given a general question, and the way you approach that question is going to be different for everyone, and that way you're still doing something that is it is coming from their end. The customization is coming from the student's end. And then you see, looking at their responses, and it has to be an iterative thing. It's not like I give you a question, you give me an answer. You
take me through the process.
Yeah, you get some hints back from them on what they're saying, and then you sort of nudge them in different directions, and you go and explore all of these things. And I was fortunate enough to have some teachers who did that with me. My brother also, who used to teach me like that itself, and then there were generally stuff outside the education system. I had people at the planetarium. Yeah, so the JN Planetarium in Bangalore. So I used to attend these classes there, which are taught by scientists themselves. And then there is the people who are permanently employed at the planetarium also for these public outreach kind of things. And it's one of my favorite learnings.
Astrophysics?
Not necessarily. Astrophysics is also one of the subjects, but generally physics overall. So it was called REAP, Research Education Advancement Program.
I have heard of it,
yeah. So one of my favorite teachers there, Mr. Madhusudan, he was an extremely busy man in terms of he uses he is the person who's responsible for the content in the planetarium shows and all of these things as well. And he has a lot of different things, a lot of different activities, outreach activities that happen there. So he's a very busy person, but he used to conduct practical sessions for us. And his way of teaching was with that limited amount of time that he was able to interact with us, he'll just have a few sentences that will make us work for hours, and we learn like crazy in that time that we are spending there, without doing so much of the work himself. He just had probably 10-15 minutes every time, and we used to work for a couple of hours based on the inputs that he would give.
That's exactly how I feel about your classes. I think you're the right person to answer. How should science be taught?
So science is not the this huge collection of facts that has to be transferred from one generation to another, which is the way it is being taught right now. That is the part which I have the most discomfort with. And the science is the way of thinking, right? It is not about Newton's laws of motion, you ratify those things, and those are necessary, useful, all of these things. They're useful if you're trying to send a rocket. You'll need to know your Newton's laws to know that you need this amount of exhaust going at this velocity for it to go at this rate, and all of these things. You will need all of those things. But science is the process of figuring this out. It is not the end result itself, and the application is useful, and everybody is focusing so much on doing that people have forgotten to enjoy this process of discovering it in the first place. It's not about knowing Newton's laws, it is about discovering the Newton's laws.
Yeah, but just imagine, it's gonna be so disappointing. Let's say you give me a problem and I come up with this whole amazing like method of solving it, and you're like, yeah, that's what Newton said. And I'm like, I thought I discovered it.
Yeah, I mean, I don't know. I would be flattered. Oh, I am Newton, is what I would take it as. I mean, I was just born late.
It's like, in Big Bang Theory, Amy's like, he's like, I'm learning how to put myself in other people's shoes. And she's like, you mean empathy? And he's like, oh, damn, I thought I came up with it. So it's like that. Yeah.
Yeah, actually, quite a few of these things, it is that process that gets you hooked, right? Where you do not know how something has to be approached. All the different lines of attack, you're going to use it. You might not solve it at all, but the lines of attack, you are going to think of what other parallels you're going to draw, and the paths you have not taken. You have explored, you've gone a lot of different directions. The paths you have not taken, that is learning, not the actual answer. Right? So the emphasis in teaching science should be that, like, how do you figure this out? Some amount of understanding of the facts and all of these things are necessary to be able to go further as well. Like, if you want to understand quantum mechanics, you will need to understand why it was necessary in the first place, and you don't have the ability to go and do those experiments that that were done to learn it. So it'll take like forever for people to actually enjoy every single thing, but at least in some of these concepts where it is actually amenable to do this, you should, right? So one of the things in terms of, like, in physics, for example, all these geometrical optics kind of things that are taught, like you're having, you have your object here, where is your image found, what is real, what is virtual image, all of these kinds of different things. Those are so amenable to people discovering while doing and fiddling things out. There are a few general principles that you're applying, and you just need to figure out that, okay, these are the things that I need to apply, and now I'll be able to solve anything. Right? So you'll get that confidence that, oh, it's geometrical optics, I'll be able to do anything with it. You can give me any funky shape of a lens and I'll be able to figure it out. I mean, this is all there is to it, kind of a thing. You will get that confidence not by ratifying, like, if object is here, then image is here. If object is here, image is there, right? So that, I feel, is the huge difference that we should have in teaching science, where process.
But I mean, majority of the engineers and people who are actually in the field of, let's say, ground level science right now have probably come from places like, coaching centers like Alan and Akash and so many other things, in which the method of looking at science itself is the direct solution, find the solution approach. How do you think, how scary is that for you?
That is super scary in two ways. I mean, not just about the coaching centers directing people to, essentially mass-produce thought.
Mass-produce thought, exactly.
It doesn't. I mean, there are a whole lot of things in the world that just needs that kind of work. You will be able to do a lot of intellectual clerical jobs, essentially, what I would call. As in, there is, in terms of, I mean, there's nothing wrong with it. It is just that
it's not enough.
You will not get these innovative things coming out of the people who are just going to be forced into a particular. I mean, you're supposed to do these things really fast and just do that. I don't believe in it. That can transfer real world skills at all to them. That is one thing. And then there is, there are a whole lot of things that will not have immediate application, and which generally we have figured it out, as entire humanity has figured out a whole bunch of things about, say, the basic sciences, which needs to be transferred from one generation to the next, which otherwise it's just lost.
It's lost, yeah.
Right? There are many things that need to die of its own. This thing, as in, there are many skills that are absolutely not useful anymore. Like back in, like, say, what Tycho Brahe's time, where Kepler's based on which Kepler's laws and all these things were obtained. Like, there were ways of calculating things using long, tedious things, and there were people who were employed to do that, right? There were just not so far. There were people who were doing the jobs of doing just calculations. You just very quickly multiply stuff. That is all that you can that you need to do, and you multiply two things and write the answer there. And then there used to be essentially chains of people doing these calculations, and then like, that is how all the moon mission and all of these things were done, or even the Manhattan Project, and all of these things had these chains of humans doing computations and stuff like that. Those things can all die gracefully, I would say. I mean, those are skills that are not really required anymore. But there are many things in terms of what we have figured out, maybe incorrect things also, but we just need to know that this is the path that we came here. We knew these kinds of things at some point. You'll not be able to retain absolutely everything that people have thought about. Like, you'll have it in writing somewhere, but you'll not have somebody who can actively think about it.
Speaking Sanskrit.
Yeah, there will be something that you can pick from even something like an Asian language, where you will be able to say, okay, these were some things that were good in this particular language that is not there in the modern derivatives of this, and then you'll have some benchmark for comparison. But none of these things will ever have a home if everybody just chooses to do that thing that has the immediate demand right now.
So with the journey from skill to, let's say, temperament, or how you look at science itself, do you think scientific temperament, that, like you said, is the journey of finding the solution, the process of it, being with the problem itself, do you think that attitude can be synthesized?
It can be inculcated. It does give a lot of joy. For me, figuring things out was the thing that gave me the most joy, like the instantaneous joy, kind of these things. Like when I was dopamine. Fine. You have this. You have this graph of all the happiness in your life, kind of this thing. There's this one sharp shooting spike. For me, that was when I was at the planetarium, and I was, I mean, it was some open problem where essentially it is something that nobody cares about. It's a problem nobody cares about. You have two divergent, rods, and you're placing a ball on it, and which way will it roll? is the question. It was a question that I framed myself as well.
Oh.
As in, so there is this particular thing that if you have a double cone kind of a thing, there are some conditions in which it will look like it is rolling uphill. So that was the basic this thing that it started, and then it was like, okay, what would happen if I don't have this double cone? If there is some other arbitrary shape?
Yeah.
And then I said, what if it's a ball? And when I placed it on it, which way would it roll, kind of this thing, and then I did a lot of calculations in theory. Like there was this big fat ugly equation that predicted that at one position it will not roll either way, and further that it will roll that way. It will roll this way, and I just rushed to this thing and saw exactly according to the equation it followed. That is, I think, the highest instantaneous.
That moment, yeah.
Okay. So that joy of figuring things out, it's a completely useless thing, right? In terms of like I'm saying the joy is not useless. I'm saying that the problem is useless. The problem is useless. But it came.
I was so confused for a moment. I was so happy till now.
Yeah. Right. So the problem is completely like arbitrary. And it has no practical application, but the amount of thinking that went into that can give you so much joy, right? That is the part that has to be, according to me, that has to be there in the whole teaching experience, where you get the people excited about something because they just need to get this craving for
that
solving.
Feeling,
yeah.
But I think I kind of sort of know what you mean, because I was telling you in the break also that gold foil experiment where the alpha particles would go through. The minute I found out that, okay, it's a ratio proportion thing, I need to find how much is in the square and then kind of derive how much it would be in the circle. That's like an inward gratification that I don't think needs any external validation. Yeah, that was damn fun.
And the thing is that it is not super hard to make classes that way, right? Maybe not on every topic, but you need to have some topics in which you're doing it that way.
It's like drugs. Like one class you feel that when you keep going up for more.
Yeah. The thing is, once you've trained yourself to do that, it becomes much easier to do that. I mean, you become very well versed in thinking like that, and then you will be able to take on even harder things after that, and it moves at a much faster pace. Like I remember when I was teaching these biological molecules, biomolecules chapter for your seniors. I took that chapter for like 3 months. That is one chapter out of some 30 chapters or something like that.
I think I remember some of them complaining about it. Like, same thing we're talking about at the end. So long.
So, for me, like those classes were about being able to build this basis on which you will be able to think of everything else much more easily once you have this solid foundation of those. And it did work out. Like after that, everything communicating, some special function of some particular protein became very easy. Like something that would have taken a few hours to communicate would happen in minutes. And then you will be, I mean, that is in terms of the facts side of things also. In terms of the process kind of things also, once you have attuned yourself to be able to, that, no matter how much you ask me, I'm not going to give you the answer. After some time, you get to this, way of trying to figure out what are all the different ways of. To me, that was all that mattered. Like you look at different ways of solving the problem instead of giving me the correct answer. That's
Do you think that's achievable for teachers all around? Do you think, like you said, maybe focusing on one topic to understand the method of enjoying the process would kind of lead on to helping them do that with other topics?
Yeah. So I think generally having open questions. I think that is something that would help a lot, where the question is so weird and bizarre, or something that you can't see, and you have to rack your brains around it for some time. There's this person who gave a talk at APU, Dr. Arthur Eisencraft.
Oh.
So he talked about this one particular thing. It was a really nice session where like he is framing a curriculum based on these open question kind of things. So he would say, I want you to make a sport that would work on the moon. Okay, so what is it going, how is it going to be different on the moon from Earth, right? You're going to play hockey.
Gravity is different.
Yeah, gravity is different. So how big should your hockey stadium be?
Oh.
Because, a human is going to hit this thing, it's going to fly much further away, right? And, you can't, but friction stays the same.
Oh, okay.
Right, so many of the forces, you need to reimagine all of your reality and question everything that you're doing on Earth
And
itself.
see what are the variables.
Yeah, what are all the things that are different? Like how high will water splash?
I remember we had a question in one of our 10th standard papers, like I'm dropping a metal ball of this weight and this size on a sand this thing, and we had to calculate the depth of the hole it made. And I'm like, bro, no. I can't do this in like an exam. Because until then I would do that, I'd get stuck with one question because I knew that I wanted to solve it. And you would be like, yeah, 5 marks for this, but you failed by. So, I know. That's pretty interesting. Scientific temperament is, I think, going to be observed differently by different people, but at the end of the day, what would you say can be like, okay, this is the right temperament?
I don't think there is a right temperament in a certain sense. So everybody has their own criteria for accepting something that somebody else has told you, right? So you have to be skeptical about anything, like say you're getting some forward or something like that. You have a fundamental distrust towards anything that has been forwarded, at least for me, right? So you're always skeptical about any information that comes. You go Google something and somebody says something, that is not proof that that is true, right? You take it with a certain amount of skepticism. And you are comparing with your internal values, what you believe in, and you're seeing how much of a match there is, and then you're choosing to keep that information in or not, right? So skepticism and the scientific temperament, all of these things are like reasonably well linked together. And you can't be absolutely skeptical about everything. Then you'll trust no one, you'll trust nothing, and you'll be a hermit sitting somewhere saying that, is this even real, and stuff like that. So yeah, you will need to find your own line of how much you are going to trust and how much you are going to sing. And each like, how do I know Newton knew his stuff? Right. Just because he says so is not. I'm not going to follow that. But am I going to test every single thing that has been discovered so far?
Then the purpose is lost.
Yeah. So the way I see science is, it's sort of like these open source movements, right? So you have, say, Ubuntu or Linux or any of these things. There is no. I'm a Linux user, and I do not know any of the source code that is going into it. But I'm trusting that there are a bunch of people who have cross-checked each other's work, that nothing nefarious is happening there. Otherwise, somebody would have flagged it and it would have been kicked out, right? So science is sort of like a community like that, where across generations people have, it is in everybody's interest to keep questioning everybody else's assumptions, right? So people build upon assumptions, and then later you find that there are discrepancies, and then people say that, do this instead, and then all your problems are solved. This whole discovery process is also sort of spanning generations, and is still staying this open to everybody else's nitpicking. And the thing is, people like in the education, like a school kid does not know that all of this has happened, right? So there is no understanding of what is the scientific process, right? Even now, like if you have to go read a newspaper and you say, there's a scientific study says that some particular eating carrots is good for some cancer or something like that, right? Like how, why, what, right? How do I mean, it's a scientific study. Somebody has done, some scientist has done something. How much do I trust that thing, right? Science itself has a metric for all of these things. It is complicated because, reality is. And people don't have the ability to question these things, and some amount of, we will just trust the experts, and there are too many experts, self-proclaimed, who don't have actual true scientific credibility, but they're very vocal. So in the populace, they seem like they know their stuff. YouTubers with doctor something in the channel name. Like, I distrust anybody who has put a doctor in the name of the YouTube channel.
I think she agrees with you.
No, as in the fact that you're a doctor something,
and you're like raving about it.
Yeah, sometimes people do it just to sound credible. I mean, there are credible people also with the doctor in their these things, but still, the trying to sound credible is the part that sort of puts me off in a certain way. Yeah, so I'd say for the students in particular, I would say that science in particular is really enjoyable if you actually take time to treat it as a discovery process and fiddle around and play around with stuff, and do your own experiments, and there is no end result you're trying to reach in any of these things. Do it for your own joy, and it is enjoyable that way. And for the teachers, I would say that there is so much that it makes your job easier. Also, you don't need to be don't need to know every definition and everything. Like in classes, I used to open the textbook and say, yeah, this is the definition, read it for yourself. But why is this definition this way? Why is it defined this way? That is the central crux that you have to focus on. And what is missed out if you miss this one clause in there? The imagination of these things, that is one thing that you should communicate across. And the biggest thing I would say is make them explore stuff rather than tell them stuff. That, I think, is the biggest thing that I would want to tell to teachers. And again, for students, I would say it is a really enjoyable subject if you don't care about scoring too much in it.
Thank you so much for watching. Please like, share and subscribe to our channel, and until next time, don't stop learning.